Okay, question 5. I hope that nobody is put off by this and maybe attempt it. Although I don't know how much use it is other than to illuminate something that's important. And we'll get to that at the end. But we are to consider, I should also say that this is Chapter 3 of Introduction to Statistical Learning, 2nd edition, question 5. Okay. So we are meant to consider our estimate of y, which is called y hat, and its formula, which is x times beta hat. And so whenever there is a hat, this means it is an estimate of. And so the beta hat is an estimate of the actual coefficient value in reality beyond our sample. And then y hat is what our model predicts y to be on the basis of the predictor variable x as well as the estimated value for beta. Okay. So we're meant to consider this where beta is given by this equation here. Okay. So already it's starting to get a little bit daunting maybe. But this is the formula for beta in linear models. So we'll just leave it at that. Without going through the derivation. There is one thing I am a little bit confused on here though, which is the little prime here, the I prime, the little what do you call that, quotation above the second I here. I'm not familiar with how to derive it that way, but and I'm not sure what it's trying to signify, but nevertheless, in my mind I think that you can just use I all the way through to indicate observation I. But so we're meant to show that we can write y hat this as this, right? Where instead of x beta we have a y. Okay, and we're also meant to answer what is ai. And we'll get to this interpretation here in a second. That's just part of the question. But it's really pretty simple. So all that we need to do is we need to take this beta, the formula for beta, and plug it into our formula for y hat, and we come out with something like this, and then we can just multiply the x through, right? So it will just go through this part, okay? And we get this equation, and we can rearrange that to look like that. And that means that all of this business here, the fraction here, is ai, and then there's our yi. Okay. Now, let's get back here to the note that's left in the question. We interpret this result by saying that the fitted values from linear regression are linear combinations of response values. Okay, this is what's important. This is what this whole question is driving at. This question is driving at in linear models, our estimates of y hat, are a scalar multiple I of the observed value for y, right? So all that we've done to arrive at our estimate is to multiply y, the observed value, by some estimate here, or by some scalar value a. And a is calculated by the observed values of the predictor variable. That's really what's important here. Okay, again, let me restate that in linear models, our estimates of y hat, are simply a scalar multiple multiplied by the observed value of y, and that scalar multiple is a function of the observed values of our predictor variables. That's all that it's saying, okay? And if you're not sure, so a linear combination is just like this. So linear combinations are the results after either multiplying or adding values, basically, right? So ay is a linear combination, and ay plus bz plus so on and so forth is a linear model, because all that we're using is sums and multiplications. Okay, so that is it for this one.